Example 4. Solve x to the fourth plus 6x cubed plus 2x squared minus 26 plus 17 equals 0 algebraically. Well, that's the same as finding the zeros of the function that is x to the fourth plus 6x cubed plus 2x squared minus 26x plus 17. So the first thing we'll do is note the degree. It's 4. So we know we have 4 total zeros. We can see from the graph, I'm getting a little bit ahead of myself, but we have a real zero of 1 that has to have an even multiplicity. So we'll have to find all of our p's and q's, all of our potential rational zeros. So remember, p's are the factors of the constant, so we have plus or minus 1 and 17. Q's are the factors of the leading coefficient, so we'd have plus or minus 1. So all of our ratios of p's over q's will just be plus or minus 1 or 17. And we do see the 1, 0 here. We know it has even multiplicity, so we'll check that f of 1 is 0. F of 1 is 1 to the fourth plus 6 times 1 cubed plus 2 times 1 squared minus 26 times 1 plus 17. So we have 1 plus 6 plus 2. 1 plus 6 is 7 plus 2 is 9. 9 minus 26 plus 17. Well, 17 and 9 is 26, so this equals 0 for sure. That is a 0. Now, we're going to use, so that was kind of steps 3 or 4 together, 3 and 4 together, I guess. And then 5 to 6, remember, we're going to keep figuring out with synthetic division how many times 1 is a 0. It's probably twice, but we'll have to see if it's more. It's definitely going to be an even. So I'll start with the factor of 1, write down all the coefficients, and use a 0 placeholder if needed, but I don't think we need one for this problem. We don't. So I'm going to do this fairly quickly because we've seen this a number of times already. And keep multiplying and adding. And we get 1 time a remainder. Now I don't always write this again. I'll just start here and I'll box another 1 right here. Remember, if I were to write this depressed polynomial, it would be x cubed plus 7x squared plus 9x minus 17. But I know I have at least one more real 0 of 1 because it touches the graph at 1, so I have to at least have the first even number there is 2 times. So I'm just going to bring down the leading coefficient here and then multiply and add. So I have a 0 again. So this was, now I went down to a cubed in this guy. Now I know I'm going to go down by 1 more degree, so this would be x squared plus 8x plus 17. So now I'm at, let's see, is this, can I factor this? No, it doesn't look like I can take 1 and 17, no way, no how, come up with a sum of 8, a positive 8. So we're going to have to use the quadratic formula. So remember that's negative b, so negative 8 plus or minus the square root of b squared, so 8 squared minus 4 times a, which is 1, times c, which is 17. And that's all divided by 2 times a, which is 1, so just divided by 2. So that's going to be negative 8 plus or minus, this will be 64 minus 68 all over 2. And then we'll clean this up a little bit. This will be negative 8 plus or minus 64 minus 68 is negative 4. So this will be negative square root of negative 4. So it's going to be 2i all over 2. Now every single one of these guys, every single term, numerator and denominator, has a factor of 2, so we could simplify this to -4 plus or minus I. So we have 2 real roots of 1, or we could say 1 real root of 1 that has multiplicity 2, and then we have 2 imaginary roots of -4 plus I and -4 minus I. So let's write those down here. We have 1, it's a repeated root twice, -4 plus I and -4 minus I. So let's roll up to the graph again just to look at it. Remember, we have the fundamental theorem of algebra says we will have 4 total zeros, and we have a real 0 of 1 with multiplicity 2, that's 2 of them, and then we have 2 imaginary zeros, -4 plus I and -4 minus I.